Did last time, we graphed the equation of the circle with center 0, 0 and radius 2. And let's do that again. 1, 2, 1, 2, 1, 2, 1, 2. It is not a solid curve because the inequality symbol does not have the equal symbol. So this is just x squared plus y squared equals 4. And now we check the inside, and the inside works with 0 less than 4. That's okay. So then all the inside is x squared plus y squared less than 4. Then we correctly identified the parabola, so y minus x squared equals 0 or y equals x squared. It's a solid curve, which is this graph. So this is y equals x squared. And now we have to pick a point that is not the origin. So let's say I pick this point and I've had 0, 5, but this is 0, 5, which makes 5 greater than or equal to 0, which is a yes. So therefore, we have to shade in the inside of the parabola. So the inside of the parabola has y minus x squared greater than or equal to 0. So then we have to intersect now the inside of the circle with the orange territory. So therefore, the correct solution is any point on the parabola and everything very, very close to the circle, but not points on the circle. So this is the solution. So the solutions of the system are found inside the parabola and the circle, not outside. My apologies. Any questions? Any questions? Okay, so let me show you again where we are. We completed chapter 4, we completed 5.1, we completed 5.4 and 5.5. So this is what is left from the entire course. So we're going to continue with 6.1 today. We probably need the entire time and maybe more. And then 8.1, and then we can start reviewing for the third test. And the final after that, okay? So 6.1 deals with a specific method of solving systems, but they are 3 by 3. So 6.1, solving systems, they are all linear, of linear equations in 3 variables. The method we are going to study is just one, is Gauss-Jordan method. If you read the book and you prefer, instead of Gauss-Jordan, Gaussian elimination, I will accept it. I don't present that method. I present the full method. Half of this is Gaussian elimination. So that's why I don't present that method. But I accept it. And I'll say, or, just for your information, Gaussian elimination. We have a choice of the method to present. If I present Gauss elimination, I present half of the method of Gauss-Jordan. If I present Gauss-Jordan, you can stop at Gaussian elimination. That's fine too. Okay? Before we even talk about anything, we have a lot of preliminaries to discuss. That one not, though. Just kidding. Okay. Number 1, I'm going to copy a system. And the system will have 3 variables. It will be a linear system. Okay, so this is from page 631. Let's say I'm going to start with problem 22. Then you choose the next and the next and the next. So problem 22, page 631. I caution you that the first problem will take like forever, but then it will be easier and shorter. I have a lot to tell you about this method, that's why. So x minus 2y minus z equals 2. 2x minus y plus z equals 4. Negative x plus y minus 2z equals negative 4. So we see that this is a system, 3 linear equations, 3 variables. Okay, number 1, the matrix of the system, also called the coefficient matrix. First of all, what is a matrix? Let alone coefficient matrix. First, let's define what a matrix is. A matrix is an array of numbers. Array of numbers. For example, I'm giving you some examples. We use brackets to represent the matrix, and normally uppercase letters. Not necessarily, sometimes lowercase letters, you will see. So here's a matrix A. Let's say 1, 2, 3, 4, 5, 6. This matrix is called 3 by 2. Why? It has 3 rows and 2 columns. Here's another matrix, matrix B. 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is a matrix that has 3 rows and 3 columns, and it will be a 3 by 3, signifying 3 rows, 3 columns. Here's another one. Let's say lowercase b. 1, 2, 3. This is also called the column matrix. How many rows, how many columns? So this is called 3 by 1. And we can go on forever. So we denote them normally by uppercase letters, and we do use these big brackets, not parentheses, and the brackets have to be there. Okay, so for now, we know what a matrix is. When I look at this system, few things have to happen. X below X, Y below Y, equal symbol below the equal symbol, free term below free term. The setting has to be this way. All X, all Y's, all Z's, equal symbol, free term. Now I'm ready to find or present the coefficient matrix. The coefficient matrix is normally denoted by uppercase A. It will have only the coefficients. A 3 by 3, of course, 3 rows, 3 columns. Can anyone give it a shot and give us the coefficient matrix? But just tell me how you dictate. You dictate by rows, you dictate by columns. Just dictate. Let's take it by columns. 1, 2, negative 1. Negative 2, negative 1, 1. And negative 1, 1, negative 2. This is the coefficient matrix for this particular system. Okay, number 2. So for now we know what a matrix is, and we know what the coefficient matrix of a system looks like. As long as the system is arranged in the correct order. X below X, Y below Y, Z below Z, free term below free term. Okay. Number 2, augmented matrix. of the system. Okay? When we augment the matrix, we augment the matrix with the free terms. You can use this notation or this notation. You can put brackets on A if you want. Some books present back brackets, some don't. I don't really care, whatever you choose. It's fine with me. So here's what happens now. See the matrix A, vertical bar B. This is exactly what we're going to have. And of course, going back to the system, this is B. Like this example, it's a column matrix with the free terms. So B will be, in our case, 2, 4, -4. That's the matrix of free terms. And when I create the augmented matrix, I'm going to copy matrix A inside 1, -2, -1, 2, -1, 1, -1, 1, -2, and 2, 4, -4. This is now the augmented matrix. First of all, let's go back to the system and see what this means. By the time we're done with this, you're going to see it will, I hope it will appear very easy to you. Okay, so let's suppose I don't have any information. I don't know anything. I'm just given this. I'm given this. I don't know what it is. I do know what it is. It's x minus 2y minus z equals 2. 2x minus y plus z equals 4. And -x plus y minus 2z equals -4. I know what it is. It represents this system. X minus 2y minus z equals 2, 2x minus y plus z equals 4, and -x plus y minus 2z equals -4. Okay? Next step. So if I give you right now something like this, will you be able to go back to the system? Quite easily, right? Okay, perfect. Step number 3. Allowed operations in an augmented matrix. There are 3 operations. 3 operations. Only 3 operations are allowed in the augmented matrix. And now I'm sure that you are asking yourselves, what are you trying to do? Forget about those operations. What are you trying to do? Here's what I'm trying to do, and then we'll talk about the operations. I want to change this augmented matrix to look like this. This is what I'm trying to do. What does this mean? It means that x is this number. What does this mean? That y is this number. And what does this mean? That z is this number. So I'm trying to change this into this. Once I'm done with that, I have x, y, and z. Because x plus 0y plus 0z is this number, which means x is this number, whatever the number it turns out to be. Then this is 0x plus 1y plus 0z, which is this number, which means y will be that number. And the same thing for z. But how do I make this into this with these 3 operations? So I wanted to give you the heads up, what are we trying to do? And then we're going to apply these operations here in a particular sequence, not just randomly. In a particular sequence, we will bring this into this, and then we'll say, we're done. We solved the system. Is that clear? Okay. Now let's discuss about these 3 operations. What operations are allowed? We cannot just come up with the solutions. We have to understand what the operations are. Number 1, number 2, number 3. I will refer back to the elimination method in a minute, so you'll see why. Okay, so going back to our system, I hope I didn't lose anyone. I know it's long. The first one is long, very long, because I have so much to tell you. Now, here's my first question. Let's suppose I don't like the way this is set up. I'm going to move this equation to be the first, and I'm going to move this equation to be the second, for whatever reason. Would that change the final solution? If I put condition 2 as number 1 and condition 1 as number 2, will that change the final solution of the system? Of course not. That's our first operation. That's the first allowed operation. Swap rows, which means swapping equations. We know each row is an equation. Why would I do that? In certain conditions, we will have to. So that's allowed. Okay. Let's go back to our substitution method for a second. So when we looked at substitution, elimination, just any of these. Okay. So here we didn't do that because there was no need, right? But am I allowed to multiply both sides of any of these equations? We're not talking about swapping them now. But am I allowed to multiply the top, let's say, by -2? If it serves a purpose, yeah, I'm allowed to, right? Good. That's a second operation. Multiplying or dividing rows by a non-zero number. So multiply or divide rows, which is equations, right? Rows by a non-zero number. If it serves a purpose, of course. I'm not going to just do it for the sake of it. Okay, now I want us to understand the last one, because the last one is slightly more complicated to think of. Sometimes we multiplied one row by -2, let's say, and we added the result to another row. Have we done that before? Let's go back to one example. This is very important to understand. And I think we didn't do that last time, but we did the time before, right? In 5.1. This is the third operation, extremely important to understand. Okay, so here's the example. Here's what we did. We decided to eliminate x. That's when we multiplied this equation by -2. We copied the -6, blah, 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 and the 6, I'm going to go back into it. And then we added to create a new equation, right? So we multiplied the first row by -2. We got this equation. We copied the second equation, and we added those. And we created a new equation. So one more time, what did we do? We multiplied one row by a number, and we added that result, each and every term, to another row, to another equation, to create a third one. Okay, so please keep that in mind. It's coming from elimination. So let's write it down, and this is the third operation. Multiply a row by a non-zero, it cannot be zero, non-zero number, and add the result to another row. Multiply a row by a non-zero number. The idea is to eliminate something, and add the result to another row. Okay. Now, number 4, before we start the method. The mandatory sequence of steps. If you deviate from the mandatory sequence of steps, you will not solve. So here is the sequence of steps. Ready? Okay, 25 minutes I needed just to go to step 4. I haven't even started the method. Okay. So the first step is obtaining a 1. This is the first step. Obtaining a 1 in the upper left corner. First row, first column. That's the first step. This is the second step. Creating the corresponding zeros underneath that 1. Only this 1, only this number allows us to get the 0 here and the 0 here. That's why this is the first point, first step, and this is the second step when we create the zeros here. The third step is creating the 1 in the next column. This is the third step. Of course, corresponding to that, this will be the fourth step. These two will be the fourth step. Once I get the 1 in the middle, I will be able to get the corresponding zeros top and bottom using this number. Using this number, I will be able to get the corresponding zeros. Of course, now you know what's going to happen. What will be my next step? What is step 5 then? Of course, the corresponding 1, and of course, this will be the last step. So once I get the corresponding 1 in the last column, this will help me determine the zeros at the top. Only now we're ready to start the method. Okay, ready? Like 5 pages ago, I had the system. Now I have to copy it again. I have to copy just the augmented matrix. So let's copy the augmented matrix, which is 1, -2, -1, 2, 2, -1, 1, 4, -1, 1, -2, -4. Okay. We have to follow the sequence of steps. One more time. The sequence of steps is this. 1, and then the zeros. 1, and then the zeros. 1, and then the zeros. One more time. 1, and then the zeros. 1, and then the zeros. And 1, and then the zeros. Okay. Lucky me. This is already done. I had, by chance, the 1 in the first row, first column already there. Awesome. But now I need to form a 0 here, and I need to get a 0 here. We do not write the equal symbol between augmented matrices. We write an arrow. They're not equal. So now I will multiply row 1 by something and add it to row 2. I will multiply row 1 by something and add it to row 3. Of course, this is row 1, this is row 2, and this is row 3. On the arrow pointing to the next augmented matrix, I have to write what I'm doing. I obviously have to use the first row multiplied by you tell me what to eliminate this. And then I multiply the first row by what you tell me what to eliminate this. So what will I multiply by to eliminate the 2? By? If I multiply by 2, I will not eliminate the 2. Think in terms of the elimination method. We have to multiply by. So this times this plus this is 0. negative 2. This times this plus this will be 0. Very good. Let's write the next step. Ready? The row we are using has to be copied. That row does not change. So now, careful. It's the elimination method, but it looks totally differently. But that's what it is. Let's do this together, please. 1 times negative 2 plus 2. Perfect. Negative 2, the next row, the next column, of course. Negative 2 times negative 2, 4, minus 1. Very good. Negative 1 now times negative 2. It's 2 plus 1. Excellent. 2 times negative 2 plus 4, 0. We finished with the second row. We will repeat with a totally different number corresponding to the third row. Ready? 1 times 1 minus 1. Negative 2 times 1 plus 1, negative 1. Negative 1 times 1 minus 2, negative 3. 2 times 1 minus 4. What have we accomplished? A lot. This is done. We can go back. We can destroy what we did. What is our next step? These were just the first 2 steps. Step number 1, getting the 1, and step number 2, getting the corresponding zeros. Where am I now? I'm here. What do I want here? Is there a way of getting that 1? Look at this row and say, sure, not a problem. You can get the 1 over there if you do what? To the second row. If you, okay, let's read the operations, the allowed operations one more time. Swap rows, not applicable. This is what we've just been doing. Multiply a row by a non-zero number and adding the result to another. But what about this one? Multiplying or dividing rows by a non-zero number. How can I get a 1 in here? Exactly, thank you. Row 2 divided by 3. Great job. Copy the first row. Copy the third row. They're not changing right now. And please tell me what to write instead of row 2. What should I write instead of row 2? Anyone? 0? I mean, we all know how to divide 3 by 3. I have no doubt. 1. 1. Excellent. So here's what we have accomplished so far. This which is done, cannot be changed, and now I have what I want in the middle. I will be using that to eliminate this and eliminate this, because that's step 4. Which row do I have to use now? In the first step, I used row 1, done and over with. In step 2, which row do I use? It has to be row 2, very good. Row 2 now will be multiplied by something and added to row 1. And row 2 will be multiplied by something and added to row 3. So remember, I'm using this to eliminate this number, and I'm using this to eliminate this number. But of course I have to multiply the entire row. I cannot just pick and choose just one number. So I multiply second row by what? To eliminate this. By 2. I multiply the second row by what to eliminate this?
1.
Very good. Which row gets copied? Because we are using it and it cannot change at this point. Row 2, the one that we're using. And of course, the first column has to be carved in stone. If I go back and I perform an operation that destroys the first column, I'm going backwards, I'll never solve. So the first column is done. The second row is copied. Now please, let's do this together. 1 times 2 added to negative 2. Perfect. 1 times 2 added to negative 1. Perfect. 0 times 2 added to 2. Good. Excellent. 1 times 1 added to negative 1. 1 times 1 added to negative 3. Excellent. 0 times 1 added to negative 2. This is done. Where am I now? I think I should make it cooler in this room to keep you awake. Okay, where am I now? Excellent. Indeed. Which entry exactly? Exactly. What do I want here so I can use it? I want a 1. So what should I do here to get a 1 in that spot? Divide by negative 2. Divide row 3 by negative 2. Great job. Please copy everything except row 3. Of course, the first 2 columns are copied in stone. We're not going backwards. So please tell me what to write in the third row. So what do we have here? 1. And what do we have here? 1. So now all this is done, including this. Final step. We multiply now which row? Which row will be used to eliminate exactly? So now row 3 is multiplied by something and added to row 1, and row 3 multiplied by something and added to row 2. Okay, ready? What do we multiply by? Negative 1 in both cases. We copy everything, meaning this. And now we stop. Okay, let's do this together, please. 1 times negative 1 plus 1. 1 times negative 1 plus 1. 0. 1 times negative 1 plus 2. 1 times negative 1 plus 2. 1. 1 times negative 1 plus 1. Perfect. 1 times negative 1 plus 0. Negative 1. Can anyone give us the solution? It's a triple. X comma y comma z. Can anyone give us the solution? What do you think? 1, negative 1, 1. X, Y, Z. 1, negative 1, 1. Do I know that this is true? No. I could have made 10 million mistakes. I have no idea. So we go back to the original problem, plug in 1, negative 1, 1, and check all the way. 1, negative 1, 1, 1, negative 1, 1, 1, negative 1, 1. So let's do this together. 1, but plus 2 is 3. 3 minus 1 is 2. Yes. 2 plus 1 is 3, plus 1 is 4. Yes. Looks promising. Negative 1 minus 1 is negative 2, minus 2 is negative 4. Yes. And now I can say yes. If I do have an error, I will not try to go through this maze. I will start from scratch to try to find the mistake. I would recommend forget it, throw it away, and start from scratch. Okay, so it took me 41 minutes to present one problem because I had a lot to explain. And now we're ready to practice. Any problem you want to pick. I can pick the next one if you allow me, or if you want to pick, please pick. We're on page 631. And this is the method called Gauss-Jordan. Gauss-Jordan method. Okay, let's pick 24 then. Now I will wait for you to walk me through. 3y minus z equals negative 1, and x plus 5y minus z equals negative 4, and negative 3x plus 6y plus 2z equals 11. I'm checking because sometimes I do copy incorrectly. So 3y minus, yes, that's correct. X plus 5, yeah, that's correct. And negative 3x plus 6y plus 2z equals, yeah, that's correct. First step, we're asked to use Gauss-Jordan elimination, or Gauss-Jordan method. So what will be the first thing that I have to present? First, I check that the system is in the correct order. And yes, x below x, y below y, z below z, the equal symbol, and the free term. So yes, the system is presented in the correct order. In the next step, I have to present the what? The augmented matrix. Very good. So how do I start? Please dictate by rows.
Can you switch them?
Yes, you can if you want from the very beginning. Yes, I agree. Why waste your time? Because you know that you have to have a 1 here, and this one has a 0. So yes, I completely agree. Brian is right. So let's do that from scratch, from the beginning. So this is 1, 5, negative 1, negative 4, 0, 3, negative 1, negative 1, negative 3, I'm sorry. It was negative 1, yes. Negative 3, 6, 2, and 11. Absolutely. Why waste the time? And you will not swap it with the third row because the third row has negative 3, right? You will only swap it 1 with 2. Very good. Awesome. Great point. It saves time. Great. Next step. I start the method from the very top, which I already have. Lucky me, I already have the 0. So at this point, I only need to get rid of this, which possibly makes it easier. Okay, so which row do I multiply and by what to eliminate that negative 3? I multiply which row? Yes, of course. Row 1 by to add it to row 3. By 3 indeed. Okay, perfect. So let's write this together. We copy the first row. We copy the second row. And now please tell me what to write in the third row. I saw that. Too late. Yes, awesome.
9.
5 times 3,
Oh,
15. 15 plus 6, 21. So 1 times 3 minus 3. 5 times 3, 15. Plus 6, 21. Negative 1 times 3. Negative 3 plus 2. Very good. And negative 4 times 3. Negative 12. Plus 11. Negative 1. So what did we accomplish? This is done. I'm checking my numbers because I really don't like this, but I have no choice. Okay, I just want to check my numbers. Did I copy correctly everything? 3 minus z minus negative 1. Just making sure. I don't know the answer. Of course. Minus 4. Yes, that's correct. Negative 3x plus 6y plus 2z equals 11. Yes. So we correctly swapped 1, 5, 1, 5, negative 1, negative 4, 0, 3, negative 1, negative 1. Correct. Negative 3, 6. We will always go back and check in the original problem. So there is, but I don't want to start with a mistake from the very beginning. Okay, perfect. So we're done with that. Our focus is here now. What do I have to have in the middle in order to be able to continue the method? What do I have to have?
A 1.
I have to have a 1. Unfortunately, I have to divide row 2 by 3, although the row is not divisible by 3, but I have no choice. So copy 1, 5, negative 1, negative 4, 0, 1, negative 1/3, negative 1/3, and 0, 21, negative 1, negative 1. So what have we accomplished? We have accomplished this, and we have accomplished this, and now we are here. Which row do I have to use? In the second step, I have to use which row? Of course, it's row 2 multiplied by to add to row 1, and row 2 multiplied by to add to row 3. I want to eliminate a 5, so then I will multiply row 2 by. Excellent. I want to eliminate 21, so I will multiply row 2 by negative 21. Very good. Which row do I copy? Because it will not change, I'm using it. Yes, row 2. And of course, whatever I built already, that cannot go back. I cannot go back and destroy that. Ready? Careful now. 1 times negative 5 plus 5. What is it? Perfect. Now let's do this aside. Negative 1/3 times negative 5 is 5 divided by 3, and I have to subtract 1, which will be 2/3. Negative 1/3 times negative 5 is still 5/3, and minus 4. So 5/3 minus 4, which is negative 12 plus 5, negative 7/3. Remember, we have to find the least common denominator. Negative 12 plus 5 is negative 7/3. Last step here. This is easier because 1 times negative 21 plus 21 will be 0. But now here I can divide. Negative 1/3 times negative 21 is positive 7. Positive 7 minus 1 is 6. Same thing here. Positive 7 minus 1 is 6. The top was slightly more difficult because I had fractions, but the last row, it's okay because I'm multiplying by negative 21. Negative 21 times negative 1/3 is 7, and 7 minus 1 is 6, the same in the last. What have we accomplished? A lot. Now this is done. Where am I? This is like a puzzle, right? So where am I now, and what am I going to do? What operation we need to perform next? Divide row 3 by 6 indeed, because I want a 1 in here. Excellent. So 0, 0, 1, 1, and I copy the rest. Ready? So now please tell me which row we multiply and by what. Of course, this is all carved in stone. This is all done. We're only trying to create the zeros above 1, the last one. So which row do we multiply by? Of course, the third row, by something to add it to row 1, and row 3 by something to add it to row 2. If we want to eliminate 2/3, what should we multiply 1 by to add it to 2/3 and get 0 there? Negative 2/3. What should we multiply 1 to eliminate the negative 1/3 this time? I want to eliminate this, negative 1/3, by 1/3. This will be guaranteed the last step. There are not that many steps, but sometimes the calculations they take time. Okay, so the final is here. 1, 0, 0, 1, 0, 0, 1, 1. So let's do this together. I copied what I had from the previous step. That will not change in this step. Okay, ready? 1 times negative 2/3 plus 2/3 at the top. What do I get? Excellent. Careful now. 1 times negative 2/3 minus 7/3. So this is negative 2/3 minus 7/3. Negative 2/3 minus 7/3 is negative 9/3, which is negative 3. Now, 1 times 1/3 minus 1/3. 1, 0. 1 times 1/3 minus 1/3. 0. Can anyone give us the triple? This is not a pair, but a triple, because there are 3 linear equations in 3 variables. What do you expect the solution to be? And I really hope so, otherwise I have to start from scratch. You expect the solution to be negative 3, 0, 1. Do I know for sure? Oh no. Nope. Especially when you talk like I do all the time. Anything can happen. Okay, so negative 3, 0, 1. 0, 1, negative 3, 0, 1, negative 3, 0, 1. I really hope that this works. Okay, 0, okay, negative 1 equals negative 1, okay. So negative 3 minus 1, negative 4, this looks promising. Positive 9 plus 2. Anything can happen, especially with fractions, right? When we had to add, subtract, blah, blah, blah. So indeed, the solution works, and this is the only one. Negative 3, comma 0, comma 1.